our last topic of the day is percent yield. So I don't know if anyone has made chocolate chip cookies, but if you guys ever look at the recipe on chocolate chip cookies, it'll often say something like yields 2 dozen cookies or yields 4 dozen cookies. That word yield means it makes, right? So a yield is like how much you produce. Okay, a crop yields food, right? So that's what a yield is like how much you can make. So percent yield is calculating how much of your product did you actually make in the lab versus how much you calculated that you should have been able to make. Okay, so as it turns out, when you make those cookies and the recipe says yields 48 cookies or whatever it is, a lot of times you end up getting 24 cookies or 36 cookies because you've eaten some of the dough, or the cookies that you made were way bigger than the ones that were expected, and so on. So anyway, same idea can happen in the lab, just with a lot more toxic results, right? So the first thing to write down, let's see, our theoretical yield is how much we expect to form using stoichiometry. Okay, so if we had our two reactants come together, we crunch out the math, we say, oh, okay, if these two masses come together, we should be able to make this mass of product, okay? All using calculators and stoichiometry, pen and paper. That's the theoretical yield. The next is the actual yield. This is how much you're actually forming in the lab. Keyword actually, okay? In real life, lots of crazy messy things can happen that can throw off your yields. So the actual yield is how much was actually formed. So your percent yield has this formula. You're going to take your actual, divide it by your theoretical, and then multiply it by 100, and that's your percent yield. Okay, it is possible, by the way, to have more than 100% yield if you accidentally measure things incorrectly. Speaking of which, other things to stray from 100% yield, sometimes you could measure things wrong, right? Obviously, measurement error. Sometimes you think you're weighing out 3 grams when it actually is 3.5 grams or whatever it is. You can also spill stuff in the lab, okay? If you're transferring from one vessel to another, that can oftentimes result in percent yield errors. You could also have contaminated reactants, okay, or bad reactants. A lot of old reactants that have been sitting on store shelves for a long time have absorbed water, and that water will throw off their masses. Okay, so bad reactants. You could also have scales that are not calibrated correctly. So scales calibrated incorrectly. Okay, so lots of stuff. If you burn your things, that'll make oxygen from the air bond with your reactants, which is something that you didn't anticipate happening. So yeah, so let's take a look at it like an example, and you guys will see what we mean. So we have calcium carbonate heated in the reaction below, so in this reaction here. And in the lab, we have 13.1 grams of calcium oxide produced. What is the percent yield of this reaction? Okay. The first thing I want to point out to you guys is that they tell us that we actually made this much of our calcium oxide. So this value is going to be our actual yield. Okay, so of the two parts that go together into the overall reaction, the overall calculation, we have the actual. It's our job to figure out the theoretical. Okay, so this is what we're going to do. We're going to say, okay, well, how much of our calcium oxide should we have been able to make if this reaction happened perfectly? So it's a stoich problem, and here's the deal. It's only one stoich problem. We're going to start with this mass, and we're going to figure out how much of the calcium oxide we need to make. So let's figure it out. We've got 24.8 grams of calcium carbonate. That's 1 mole of CaO3. Oops, CaCO3 has a molar mass of 100.09 grams. Again, we're solving for the calcium oxide. That's a 1-to-1 ratio, so 1 mole of calcium oxide and 1 mole of calcium carbonate. And we need to get that into grams, and so now we're in calcium oxide. 1 mole of calcium oxide has a mass of 56.08 grams. Okay, crunching this stuff out, we'll find out that we could make 13.9 grams of calcium oxide in the perfect world, okay? So this value represents the theoretical value. If we were to do this and had no error whatsoever in our lab, this is how much we theoretically could make. So we have our theoretical mass and we have our actual mass. Now we can calculate our percent yield. It is that simple. So we're going to do just like they say, actual over theoretical and multiply by 100. So we'll have 13.1 grams of CaO divided by 13.9 grams of CaO multiplied by 100, and we end up getting 94.2% yield. Not a horrible yield for a lab. Could be better, could be way worse. So there you go, that's how you do percent yield.